Thank you. Well, each of the conferences every 2 years, I've given an update on my estimation of the population of NEAs. Do I push this button? Do I have to point it somewhere to make it advance? No. I point it toward the screen to do that, and then the arrow. Okay. My grandkids know how to do this, but I'm a little beyond it. Whoa. There we go. My method of population estimation is to take a 2-year sample of the discovery or detections from all of the surveys, major surveys, and then from those detections derive for each size bin the ratio of objects that are redetections of already known objects and the ones that are new detections of objects. And the new detection, that ratio, in principle, if discoveries were random, that ratio would be equal to the completion of the survey in that size. But in fact, it's the blue curve over there is that redetection ratio. In fact, surveys tend to find the easy ones first, of course. And so for real distributions of orbit elements and so on, the completion lags a bit behind the redetection ratio, and the red curve there is the estimated completion corresponding to the redetection ratios in there. The blue data points are the actual redetection ratios that we find from the survey, and those are done in relative magnitudes, and I just slide that plot laterally until it matches up as best fit to the theoretical curve, and that'll essentially calibrates the survey and allows me to estimate the completion, the red curve, in terms of absolute magnitude on the bottom scale there. And then I can estimate populations from that, from the known numbers actually detected. Now then, the good news, I suppose, but makes my talk a little bit boring, is that this year's analysis fell bang on top of 2 years ago, which was good news for the NASA administrator and for Lindley Johnson, who quoted to you some of the 2-year-old numbers, but they're virtually unchanged from this year. They're within a fraction of a percent typically in all aspects. So that's also good news for me, because that means that my survey technique or my estimation technique is not showing a systematic bias that marches along every 2 years to a different answer. That's worrisome to people that do this kind of analysis. So it looks really quite good. Okay, there's the new versus old numbers up there. Is this do a red thing or something? I think it's a virtual pointer. I think the battery kind of went dead on it. Anyway, the number, my latest estimate of the number larger than 1 kilometer is 942 compared to 934, so it changed like less than 1%. The fraction discovered did go up, so we are now about 94.5% complete. If you look at the number from those statistics, the number of undiscovered, the estimated number undiscovered yet of larger than 1 kilometer has gone down from around 62 to about 52. The numbers are a little different because the estimated population changed a bit. If we look at that H absolute magnitude of 22, which is 140 meters size, 140 meter and larger, I now estimate that we are 37.6% complete, and that is just a little bit more than the number that was quoted this morning of 1/3. And so, of course, there the news is that we're getting more and more complete at a pretty good rate. Now then, it turns out even with those completion numbers, a substantial fraction of the risk lies in the very smallest objects. And so we'd really like to quantify as best we can how many of those really big guys are still out there. Here is a plot. Whoa. I'm pushing the wrong button. One last. Yeah, here's a plot of several of the very largest sizes. The green curve is the 1 kilometer size, and then it goes up to a few kilometers. You can see that at 1 kilometer, and that's a differential plot, so that doesn't include the still larger ones, the completion is, about 90% or so right now of the smallest of that set of 1 kilometer and larger. As you go to the larger ones, we're more and more complete, and the very largest sizes, the thing that's rather interesting is that they kind of asymptotically approach about the same level of completion of about 0.02 or so. That is about 98% complete and 2% remaining undiscovered. I think that's my interpretation of that. It's because at the very large size, the remaining undiscovered ones have been hiding from you. And the second they come out of hiding and peek out from behind the tree, any survey, a backyard telescope even, will find them because they're really quite bright. It's just that so far they've just not come into view. Here we see another representation of that. This is the fraction per year discovered ever since 2000. The blue curve is this very small size where we still don't have much completion, and the fact that that curve is sloped upward by an order of magnitude in 20 years indicates that the surveys have gotten an order of magnitude better or more powerful in that amount of time for detecting asteroids. Meanwhile, the big objects have gone cascading down because we get closer and closer and closer to completion, and it kind of looks like the very largest objects follow a kind of discovery curve with a half-life of about 5 years. That is, that asymptotic curve has about every 5 years we reduce the number remaining undiscovered by about a factor of 2. If you believe that, it's a simplistic model, you can then plot up the populations that remain undiscovered and estimate how we're going to do in the future. And I drew a line across at an estimated population of 1. That's kind of when you would expect to discover the very last one of that size. For 1 kilometer objects, that will happen just about 2030 or 2040, I believe. Around 2040, if the surveys continue the way they are now. Another question you might ask is, what is the very largest one that still remains undiscovered? And the answer to that looks like it's something around 3 kilometers in diameter. So there might be one more 3 kilometer object. So the next question we might ask is, where are they hiding? Where are these big guys hiding? Well, this is a plot of the remaining undiscovered theoretical, that is model survey, undiscovered objects, the 2% undiscovered at the end of 20 years of surveying. And interestingly enough, in the vertical scale of semi-major axis, and a huge bunch of them are set at 1.0. Those are the ones that have a 1 year period or very close to 1 year period. They're hiding behind the sun, and we just have to wait till they come wandering around. There's also at the resonant points, a 2 year and 3 year and 4 year periods. Those are hiding behind the sun when they come to perihelion, and at aphelion can't see them. So that's kind of where they're hiding. A fair fraction of the very biggest ones are hiding in resonant orbits, and they're basically parked behind the sun, but slowly moving out because they're not really on true resonance, they're just near commensurability. A couple of further considerations on that is that PHAs only constitute about 20% of the NEA population. So in a sense, when we get down to having only 5 NEAs of a given size left undiscovered, we're down to only 1 PHA left undiscovered. And so the news is a little better than that. And in fact, we would expect to discover the last potential hazardous impactor of, say, 1 kilometer, more like 2030 rather than 2040. And the other consideration to think about is that because of this resonance business, the asteroids that come out from behind the sun are going to kind of loop around. And so they'll come into survey visibility long before they actually will be on an impact trajectory, or even if they are on an impact trajectory, you'll have a lot of time to find them. Okay, there's my conclusion. I'll just leave them up.
Great. Thanks very much, Al. Okay, so we got time for a quick question. Go ahead.
Hi, Al. Great talk. Just want to point out one thing to the community, and also that I think we need to think about, and that is there's a paper by Ned Wright that shows that if you want to be 90% complete at 140-meter objects, because of albedo, you actually have to be 90% complete at 23rd magnitude, so H of 23. And so have you looked at, kind of what the completeness is there compared to the completeness at?
No, I haven't, and I would add to that in my opinion, the largest remaining uncertainty that we have in population is the question of albedo and albedo distribution. And of course, the infrared surveys will go a long way to improve that situation. So I think your point is correct. I'm just speaking of the averages. By the way, Tim Spar made a big deal about the disparity between the estimated population and the bolide frequency. And I really think that factor of 2 difference is primarily uncertainty in knowing albedos, densities, diameters, energies of impact, and so forth. So I don't see that as a big problem. I think factor 2, man, that's really pretty good when you extrapolate 5 orders of magnitude.
Definitely in astronomy, yes. All right, so thanks very much to Al. I'm so sorry. I'd like